All right, ready to dive deep. Today, we're going way back into the world of 1970s military communication.
Oh, yeah.
We're talking about the ANPRC-70 radio set,
Cool.
using the original U.S. Army technical manual from 1975 as our guide,
Wow, 1975.
full of diagrams and specs,
Uh-huh.
and even some pretty interesting warnings.
I bet.
By the end, you'll have a good idea of how this radio worked,
Okay.
the different ways it was set up,
Right.
and even get a sense of what it was like to operate with the threat of enemy jamming.
Back in the analog days,
Exactly.
this radio was vital for U.S. troops back then.
Yeah, before the internet and cell phones.
Before GPS even.
Right, coordinating missions and sharing intel with just this analog device.
Must have been quite a challenge.
So, to start,
Yeah.
what does ANPRC even stand for?
Well, it's not a secret code, actually.
Okay, good.
AN means Army-Navy.
Ah, makes sense.
It's a joint designation system.
I see.
And PRC stands for Portable Radio Communication.
So, a radio designed to be carried by soldiers in the field.
Exactly, not stuck in some command center.
And speaking of carrying it,
Yeah.
the manual mentions rucksack frames, carrying bags, specific packing instructions.
They really thought of everything.
It seems like they planned for any situation.
Absolutely. They designed it with mobility in mind,
So one or two soldiers could carry it.
depending on how it was configured.
The detail in the manual really shows
What's that?
how crucial this radio was.
Oh, for sure.
So let's get into the specs now.
All right.
The manual mentions a frequency range of 2 to 30 megahertz.
Yeah.
What does that tell us about what it could do?
Well, that puts it in the high frequency band,
Okay.
ideal for long distance communication.
Especially in tough terrain.
Right. But it wasn't just about distance.
Oh, okay.
The ANPRC-70 could operate on several modes.
Multiple modes.
Like FM, AM, single sideband,
single sideband.
SSB for short,
Okay.
continuous wave, CW, and even frequency shift keying.
FSK.
Right.
You got it.
Wow.
Yeah.
Why so many modes? Well, think of it like having different tools.
Okay.
Each mode had its own strengths and weaknesses.
Different situations.
Exactly. FM was good for clear voice communication.
Over shorter distances.
Right. And SSB was better for long range.
Even with interference.
Yeah. So having all these modes,
Gave soldiers more tactical options.
they could adapt to the environment and the mission.
Flexibility was key.
You're sure?
What about power? How long could it run?
Well, it depended on the power output.
Okay.
On low power mode, it only drew 7 watts.
To save battery life.
Right. But if you needed to reach further
You could crank it up.
to high power, a full 160 watts.
Wow, that's a big difference.
It is
How far could you communicate with that much power?
potentially miles.
Miles.
Yeah. But of course, terrain and atmospheric conditions played a role too.
Makes sense.
But the ANPRC-70 had the power to reach far-off units.
And to reach those distances?
Ain't a good antenna.
Right. And the manual goes deep on the different setups.
All sorts of configurations.
It seems like soldiers had options, depending on how they were using the radio.
It all comes back to adaptability.
Right. That seems to be a theme.
It is.
So a soldier on the move might use the whip antenna,
A basic one.
like you see in movies,
Exactly.
but for something more permanent.
The options get a lot more complex.
Oh, yeah.
For stationary operation,
Uh-huh.
they could use doublet antennas,
Okay.
which are basically 2 wires.
Like a clothesline.
Exactly. And for really long-range communication.
There was the low radiating angle antenna.
The big one.
The manual says it needs 2 15-foot masts.
Yeah, and it ends up being 300 feet long.
That's longer than a football field.
It is. This thing was huge.
Designed to bounce signals off the
To
atmosphere.
reach incredible distances.
I can't imagine setting that up in the field.
Hauling all that equipment potentially under fire?
Right.
It shows how important communication was.
And the lengths they'd go to maintain it?
Absolutely.
It makes you appreciate modern communication tech.
So much easier now.
We've got this powerful radio,
Uh-huh.
adaptable configurations.
Right.
But how easy was it to actually use in the field?
Well, that's where ease of use comes in.
Okay.
They designed it for soldiers under pressure.
Who wouldn't have time for complicated controls?
Right. The manual has step-by-step procedures.
With diagrams and explanations.
It was all about simplicity.
But I'm sure there were still some quirks and challenges.
Oh, definitely.
Like what?
Well, one of the most interesting things I found
Okay.
was a warning about using trichloroethane near an open flame.
Trichloroethane.
Yeah, a solvent.
Okay.
Apparently, it creates phosgene gas.
That doesn't sound good.
Not at all. Very dangerous.
So they were using a potentially dangerous chemical to clean this radio.
It seems that way.
It's a glimpse into the realities back then.
Yeah, the risks they had to take.
To keep the equipment working.
They knew the risks, but also knew that keeping it clean was essential.
It's a balance between function and safety.
That soldiers had to deal with.
So they had their work cut out for them.
Just keeping it running.
And then there's the enemy jamming the manual talks about.
Oh, yes. Jamming.
What did that involve?
Jamming was a type of electronic warfare.
Okay.
A way to disrupt communication.
By interfering with radio signals.
Exactly. Imagine trying to coordinate a mission,
Wow.
and all you hear is static or noise.
Or even enemy propaganda.
That's right. It could be very dangerous.
The manual describes different types of jamming used back then.
Yeah, it does.
Can you explain those?
Sure. One technique was continuous wave jamming,
Okay.
which basically blasted a steady tone.
So it would mask other signals.
Like someone holding down a single note on a piano.
Drowning out everything else.
Exactly, trying to overpower the desired signal.
Both force.
In a way,
What other tricks did they have?
another technique was modulated jamming.
Okay.
Instead of a single tone, they'd use noise, music, or other sounds.
To create interference.
It's like trying to talk in a crowded room.
Where you can barely hear anyone.
Exactly.
That's pretty sneaky.
It
Is
was.
there anything even more disruptive?
Maybe the most frustrating one was sweep-through jamming.
Okay, what's that?
Imagine a signal that's rapidly changing frequencies,
Sweeping across the spectrum.
disrupting anything in its path.
But which constantly change channels.
You got it, making it impossible to communicate.
Wow, that sounds like a nightmare.
It was.
The fact that they dedicated a whole section of the manual to jamming,
Shows how serious a threat it was.
they were prepared.
Definitely.
Well, we've covered a lot in this first part of our deep dive.
We have.
Unpacked the ANPRC-70 specs, explored the different configurations,
Yeah.
and even delved into enemy jamming.
Back in the analog days.
Exactly. Welcome back. Last time we laid the groundwork,
We did.
exploring the ANPRC-70's capabilities and challenges.
All that good stuff.
But I really want to see those configurations,
Yeah.
how they actually looked.
It's cool to see it visualized.
The manual's full of diagrams,
Yes.
so let's bring them to life. Science.
Let's start with figure 2.1.
Okay.
It shows the one-man portable setup.
Huh.
Everything is so compact,
Yeah.
it really was designed to be carried by a single soldier.
Picture this.
Okay.
The radio strapped to the soldier's back,
Uh-huh.
battery pack below for balance.
Makes sense.
And for the antenna, they had options.
Options.
A whip antenna on an adjustable base.
Right.
It could be attached right to the radio
Okay.
or extended with 6-foot or 9-foot
To
sections.
get more range.
Exactly.
So even the most basic setup had flexibility.
Always.
And this one-man portable setup,
Yeah.
it was mainly for voice communication.
Primarily, yeah.
The handset connected directly to the radio unit.
Perfect for quick communication on the move.
Now, if
Yeah.
we jump to figure 2.2,
Right.
this the one-man stationary configuration.
Uh-huh.
This one looks a bit more complex.
A little more involved, yeah.
Here, it's about a more stable post.
More permanent, right.
Yeah, like at a base or observation point.
The radio unit sits on a rigid antenna base
And connected to a grounding stake.
for stability.
Yeah, have that?
And the antenna options change, too.
Yeah. Oh,
Not just the whip antenna anymore.
right. They could still use the whip antenna,
Okay.
but now they had a choice of 6, 9, or even 15 feet,
Wow. 15 feet.
depending on the range they needed.
That's pretty tall.
And there's something new in this diagram.
Oh, what's that?
A headset connected to the radio.
A headset.
Yeah, and a telegraph key.
For Morse code.
You got it.
So it wasn't just voice comms anymore.
No.
They could send coded messages, too.
Relaying intel back to headquarters.
I see. Communication played so many roles.
It did.
Now things get really interesting.
Okay, I'm listening.
With the two-man configurations,
Like figure FO4.
this one shows the doublet antenna setup.
The clothesline one.
Right. It's way different from the simple whip antenna.
This was for maximizing range.
Across the whole 2 to 30 megahertz range.
The whole
The
thing.
diagram shows two 15-foot masts, each one made of 5 3-foot sections.
That's right.
Two soldiers working together,
It's assembling those masts
connecting the wire and the balloon assembly.
and grounding everything properly.
It was a team effort.
For sure.
And if they needed more height,
Yeah.
they could combine those sections to make a 30-foot mast,
Wow. 30 feet.
taller than a 2-story building.
That's high.
Talk about going the extra mile
Literally.
for
they-
clear communication.
It really shows the dedication.
Yeah, and ingenuity.
They were building a mini communication tower.
Adapting to whatever they faced.
Exactly.
These configurations are so adaptable.
The ANPRC-70 was very versatile.
It wasn't a one-size-fits-all solution?
No, it could evolve with the situation.
So let's move on to actually operating this thing.
All right, good stuff.
The manual goes into the procedures, and right away I noticed something interesting.
What's that?
They say no damage will come from improper settings.
Okay.
But then they say battery life will be shortened by some settings.
So which is it?
Will messing with the controls damage it or not?
Well, it's about emphasis.
Okay.
They wanted to reassure the operator
That the radio was tough.
and could handle some mistakes.
Okay.
But they were also reminding the soldier,
That every action has consequences.
especially for battery life.
Out in the field.
Every adjustment could impact how long it ran.
So experiment, but be mindful of the battery.
You got it.
The manual even gives a tip to save battery.
What's that?
Only use the dial light when you absolutely need it.
Every bit of power counted.
It did. So let's walk through the startup procedure.
Okay.
The manual lays it out step by step.
Yeah.
What's the first thing a soldier would do?
First, they'd set the power switch to RCV only.
Receive only.
Basically turns it on, but keeps it from transmitting.
So you're listening before broadcasting.
Exactly.
Next, you adjust the volume.
To a comfortable level.
Makes sense.
Then comes a crucial step.
Okay, what is it?
Momentarily setting the power switch to tune.
Yep.
This activates the automatic tuning coupler.
What did that do?
It sets the radio to the desired frequency.
How long did that take?
About 10 seconds.
Just 10 seconds.
During that time,
Yeah.
the radio analyzes the signal
Uh-huh.
and finds the optimal settings for clear communication.
And then you're ready to transmit.
Once tuning is complete,
Okay.
you set the power switch to either HIPWR or LOPWR,
High power or low power?
depending on how far you needed to communicate.
And how much battery life you had left.
Exactly.
The manual mentions a compatibility issue
Oh, yeah.
with other radio systems.
What kind of issue?
It says it wouldn't work with FM sets having 25 kilohertz channelization.
Unless a modification was done.
So connecting with some units,
Could be a challenge.
but they had it fixed.
You did.
The manual says support personnel could do a modification.
So it wasn't a deal breaker.
No, but it needed some know-how to fix.
That's right.
Now let's talk about those special tuning procedures.
Okay.
What happened when the automatic tuning wasn't enough?
Well, this is where it gets interesting.
Okay, I like interesting.
The manual acknowledges
Huh.
that sometimes the environment interferes with the signal.
I can see that happen.
And their solutions.
Yeah.
They're a little strange.
Give me an example.
One suggestion is to change the environment around the antenna,
Like what?
moving objects near the antenna,
Object.
including the operator.
The operator themselves.
Yeah, other people.
Okay.
Even the handset cable.
So they're suggesting physically moving things around.
It sounds like trial and error.
Not exactly scientific.
Well, remember,
Keep going.
this was before we had digital tuning tools.
Right, makes sense.
They were working with what they had.
I see.
Sometimes a simple solution.
Like moving the antenna.
Or even the operator
You
themselves.
have to make a difference.
It shows their resourcefulness.
Yeah, and adaptability.
They were finding creative solutions.
Overcoming limitations.
Exactly.
The manual also suggests changing the frequency
In 100 kilohertz steps.
until it finds one it can tune to.
And then switching back to the desired frequency.
Right.
And sometimes they even recommended using different antennas altogether.
So they encouraged soldiers to experiment
They try different things.
until they found what worked.
That's right.
We've come a long way from that.
Plug and play technology.
It highlights how important it was to understand the tech.
Not just following instructions.
They had to troubleshoot on the fly.
Adapt to the situation.
Now we've covered the diagrams and the procedures,
Yeah.
but there's one more thing.
What's that?
Enemy jamming.
Right, jamming.
Last time we talked about the types of jamming,
We did.
but how could an operator actually counter it?
Well, jamming is a deliberate disruption.
The enemy wants to stop you from communicating.
Exactly. So the first step is recognizing it.
But how could you tell?
How could you tell it was jamming?
Yeah, how could you differentiate between normal interference and jamming?
Well, the manual gives some clues.
Okay, what are they?
Like, if you suddenly get strong interference
Uh-huh.
on a frequency that was clear before,
That's suspicious.
or if the interference seems to follow you,
As you change frequencies,
that's a sign you're being targeted.
it's like a game of cat and mouse.
Trying to stay ahead of the enemy.
So how could you counter that?
There wasn't one magic solution.
Okay,
It depended on the type of jamming.
I see.
The manual suggests different techniques.
Like what?
One approach was to try and outmaneuver the jamming signal.
To outmaneuver it?
Like if it's a continuous wave jam,
Okay.
you might find a clear frequency nearby
So basically, dodge the interference.
by moving to a different frequency.
What about those more complex types of jamming,
For something like a sweep-through jam.
where it's constantly changing?
Yeah.
You could try transmitting in those brief moments.
When the signal is sweeping past your frequency.
So it's all about timing.
And a little bit of luck.
Sounds tricky.
It was.
Any other strategies?
They also suggest reducing power output or changing the antenna configuration.
To make your signal harder to target.
Exactly. Less predictable.
Outsmarting the enemy.
Adapting to their tactics.
The manual also stresses training
For operator.
to recognize and react to jamming
Soldiers need to be able to identify it.
and understand its effect.
You know how to respond quickly.
Because in battle,
Yeah,
a disrupted communication line can be disastrous.
absolutely.
We've gone from understanding configurations
Mm-hmm.
to operating the PRC-70
We have.
and even delving into electronic warfare.
It's been a journey.
We've seen how resourceful soldiers had to be
Adaptable
and quick thinking.
to overcome these challenges.
But our journey isn't over yet.
no, it isn't.
So we've explored the PRC-70's versatility and how soldiers dealt with enemy jamming.
Right.
But let's be real.
Yeah,
Even the toughest tech needs maintenance.
it does.
What did the manual say about keeping this thing working?
The maintenance section is really detailed.
It is,
Yeah, the Army knew a radio is only as good as its upkeep,
especially in those environments.
especially in the field.
We already talked about the trichloroethane warning.
Oh, yeah.
The solvent that could create phosgene gas.
Not good.
It seems like they emphasize safety a lot.
They did. They weren't messing around.
The manual stresses ventilation
When using it.
and warns against getting it on the controls.
Or connectors.
It's a reminder of the challenges they faced.
Using hazardous materials just to keep things working.
So even routine maintenance could be risky?
It could.
What other cleaning procedures did they have?
The basics were pretty familiar,
Familiar.
like using a damp cloth to remove dirt,
Okay.
mild soap and water on the controls.
So pretty standard stuff
Nothing fancy, but essential for preventing corrosion.
to keep it running smoothly.
That's like they were saying,
Oh,
even in the field, a little cleaning goes a long way,
makes sense.
right?
What about more in-depth checks?
To make sure everything worked. They had a whole section on operational checks,
Okay.
divided into two categories.
The categories.
Operator crew maintenance
Okay.
and organizational maintenance.
So different levels depending on the complexity.
Exactly.
So operator true maintenance.
That was stuff soldiers could do themselves.
In the field?
Simple but important checks.
Like what?
Making sure the battery was installed right.
Okay.
Checking for damage. Making sure the controls worked.
So basic checks.
Think of it like a pre-flight checklist.
Okay, I get it.
And organizational maintenance.
Yeah.
That was more involved.
More specialized.
Like taking your car to the mechanic,
Yep.
done weekly, included inspecting the antenna, checking connections,
Right.
making sure the battery held a charge.
Wow, thorough
They even had instructions on repainting the radio.
repainting.
Yeah, with cautions about not painting certain surfaces.
That could interfere with operation.
Exactly.
They were meticulous.
They were.
It really shows how vital this radio was.
Yeah. They couldn't afford for it to fail.
Especially during a mission.
Right.
And if they had problems,
Yeah.
the manual had troubleshooting charts
To help pinpoint the issue.
and find a fix.
It was all about keeping those communication lines open
So they had the tools and the knowledge.
to keep it running.
But as we wrap up,
Yeah.
I'm curious about the bigger picture.
What do you mean?
What was the PRC-70's legacy?
Ah, good question.
How did it influence later tech?
Well, it was groundbreaking for its time.
It was
Oh, yeah, it showed the importance of good design.
in military communication.
Robust, versatile, user-friendly.
It set the stage for future developments.
The emphasis on adaptability, modularity.
But of course, technology has moved on.
We've come a long way from those analog days.
We have.
Today's military communication is all digital.
Right.
Software-defined radios, encryption, anti-jamming,
But the core principles remain.
reliability, security, adaptability.
Still important today.
And it's fascinating to see how those principles were there
Back in the 70s.
in ANPRC-70.
It's like a reminder that innovation builds on what came before.
The ANPRC-70 might be old
But it had a real impact.
on communication tech.
So, as we sign off,
Yeah.
think about how far we've come
From analog radios.
to today's digital systems.
But the challenges are still there.
The need for secure, reliable communication.
In tough situations.
It's a constant evolution.
Human ingenuity at work.
Thanks for joining us on this deep dive
Into the world of the PRC-70.
Until next time, keep exploring and learning.
And keep those communication lines open.